Equation of a line. So, 3 equations of a line. Linear lines. All right, lines called linear. What's a linear line? Actually, let's start with that. Straight line. All right. What's the most basic equation of a straight line? Y is equal to x. Oh, give me like the general mx plus b. You're right, but mx plus b. All right. What does m represent? The slope. You'll see that that's a reoccurring theme in calculus. Slope. And there is a formula. There's rise over run, but do you remember this formula? y2 minus y1 over x2 minus x1. Remember seeing that? Now there's also point slope equation of a line, which is y. It's basically this formula rearranged. If I multiply this x2 minus x1 up here, you end up with y minus y1 equals m x2 minus x, or x minus x1. That's what I wanted. That's point slope because it gives you the equation of the value of a point and the slope of a line. And then the one that nobody really uses, but they write it a lot, is general form. Ax plus by plus c is equal to 0. Remember that? Where you move everything to one side, you set it equal to 0, and everybody in grade 10 complains because you don't really ever use it. It has value when you start to reach the level of math that you will reach in university because you can use it to represent three-dimensional things. Three-dimensional things are not lines anymore, they're planes. Okay, so you need 3 values, x, y, and z. Have I talked about this before? I feel like maybe it's just my grade 10s. If we just plot x and y, right? There's actually a third one, if you think about it, that comes out and goes back. And that'd be z or z. Okay? And that's where general form comes into play. All right? We're not going to use it that much, although the book writes a lot of its answers in general form. We're mostly going to use these two. Okay, so a basic question. So find, and this is going to come up in this class, so that's why we're going over it. Find the equation of the line with slope 3 and passes through the point 1, -2. Okay. What do we do? So there's 2 ways to do it. You can use mx plus b or you can use point slope. It doesn't actually matter. So if you do mx plus b, all right, you plug in your slope and your point, because that's the x, that's the y. 3 is the slope, 1 plus b. So -5 is equal to b. So the equation of the line would be y is equal to 3x minus 5. Remember that from grade 10? Maybe. The other way to do it, and I don't care which method you use, some people like to use, because we have a point and a slope, the point slope equation, to use that one. You plug in your slope and your point is x1, y1. So it would be y plus 2 is equal to 3x minus 1 And then you just move the 2 over, and you get the same thing. So it's up to you which one you want to use. I don't care, but this type of question will come up. All right. Is that okay? All right, second type. Find the equation of the line which passes, or that passes, I guess. Passes through 2, -1. And is perpendicular to the line 2x minus 3y minus 5 is equal to 0. All right. So, what do we need to do? Yeah. So, in this one, rewrite this. Is that what you're saying? Yeah. So this one that says perpendicular, if you see the word perpendicular, they're talking about slope, right? So that means I have to rewrite this equation to figure out the slope of that line. So I'm going to move the y over. So I'm going to go 2x minus 5 is equal to 3y. And then divide off the 3. So what's the slope of this line? 2/3, right? The number in front of the x. So the slope of that line is 2/3. But I don't want the slope of that line. I want the slope of a line that is perpendicular. If you have perpendicular slopes, how do your slopes relate to each other? You flip it and throw a negative in front, because perpendicular lines meet at a right angle, right? So if the slope of this line is, say, 2, or I'll just say 2/3, then the slope of this line, which I'll call, that's my little symbol for perpendicular because they meet at 90 degrees, I will just say is -3/2. All right? And then just accidentally use the exact same numbers, but that's okay. So the slope of the perpendicular line to this line is, so m perpendicular, flip it, and throw a negative. So -3/2. So now we have our slope, and we have our point, and then it's just like the other equation, or question. So we just go, I'll just do mx plus b. -1 is equal to m. Plus b, -1 is equal to -3 plus b. Two is equal to b. So the equation is -3/2 plus 2. Is that okay? This sort of subtly bringing back memories from grade 10, hopefully. All right. Is that okay? Okay. Let's go get our books. Go on a field trip, people. All right, domain and range. First one there, x squared minus 4. What does that graph look like? Let's talk about the graphs too. He's called a parabola. Parabola shifted 4 units down? Yes? Yes? Because it's a quadratic? Opens up? Yes? Okay. When do you have domain restrictions? So you have domain restrictions when you have a variable in the bottom, such as that, or you have a square root, or an even powered root, right? Because you can't root a negative number when it's an even power. So does this parabola have anything in the denominator? It does not. So what is the domain? So you can say XCR, which means X is all real numbers, or negative infinity to positive infinity, right? It can be anything between negative infinity and positive infinity. What is range? Yeah, so range is all possible y values. You can see the lowest y value is -4, so y is greater than or equal to -4. If you're going to write it in interval notation, it goes from -4 to positive infinity. What's on the -4? It's a square bracket. So if you don't know this notation, a round bracket means it does not include the number. So infinity is always a round bracket because you can never get to infinity. A square bracket means it includes the number. All right. So that's why the -4 has a square bracket on it. Okay. 1 over x squared minus 4. Are there any domain restrictions? Values that x is not allowed to be? 2. 2 would be one of them. And -2, right? Because basically, if you're doing the math, you would just say x squared minus 4 cannot equal 0. So x squared is equal to 4. You square rooted both sides. X cannot equal plus minus 2. So if you're going to write that in whatever, inequality formation, I guess, even though it's not, you'd say x cannot equal plus or minus 2, and then you'd say XER. It can be anything except plus or minus 2. If you're going to write it in interval notation, it's easier if you think of the graph. Does anybody know what that graph looks like? Does it have asymptotes? Yeah. It has vertical asymptotes of plus minus 2. All right. And then this one, if you actually tested the point, if you put 0 in for x, you're going to get 1 over -4. So it actually looks like this. That's what the graph looks like. we get into curve sketching, so I'm not too worried if you don't know what the graph looks like. That's fine. I just want to get into notation of domains and ranges. All right. Oh, and it has a horizontal asymptote, I guess, at 0. Okay, so the domain we said is x is unequal to positive negative 2 or XER. If you're going to write that in interval notation, it's kind of a different way of writing it. You would say it can be anything from negative infinity, which is way out here, all the way up to negative 2. So you'd go negative infinity to negative 2. Go away. It can't be negative 2, so it's both rounded. Then it goes from negative 2 to positive 2. Again, doesn't include those. So they're rounded. And then it goes from positive 2 all the way to infinity. And there's a new notation that you'll see sometimes. This is why I'm doing this. So these are, when we include all these together, we call that the union of all these things. And it has that. So it's the union of this set and this set and this set, which means it includes all those things. In this way, it's actually easier to write the domain this way than it is in interval notation, because interval notation, you have to write the whole thing out. Okay. We got 10 minutes left. All right, we'll do this. It's the last one. F of x is equal to root x plus 2 minus root 2x plus 1. Oh, I didn't do the range for the one above. What's the range? This is domain. Domain. What's the range for the one above? What's the only value it's not allowed to be? 0. So you can say y cannot equal 0, y-e-r, or you could say negative infinity to 0 and 0 to infinity. Domain is just kind of woven throughout the course. That's why we're kind of looking at it right now. And I just don't want you to freak out if you see this kind of stuff. All right, last one for the day. Root x plus 2 minus root 2x plus 1. So what numbers are you not allowed to square root? Negative numbers. So to figure out what the domain restriction is, you look at each square root separately. So we go, you take what's inside, and you go, okay, x plus 2 has to be bigger than 0. Can it be 0? Can you square root 0? You can, right? So it's greater than or equal to 0. Okay. So I solve that. I get x is greater than or equal to negative 2. Okay, fair enough. Then you go over to the other one. And I take what's in there and I go, okay, 2x plus 1 must be bigger than 0. So I move the 1 over. It's greater than negative 1. Divide by the 2. X is greater than negative a half. So you have two restrictions now. I want just one. One domain that will give me all the possible answers. So if you put them on a number line, you can see it. Negative 2 is there. Negative 1/2 is there. And then you just draw them. So x is greater than or equal to 2. Greater than or equal to means it includes the numbers, so it's a solid circle. We're bigger than negative 2, so we're going that way. Okay? And then you say, okay, the other one. X is greater than or equal to a half, negative a half. Includes the number, going that way. And then you ask yourself, where do they overlap? Yeah, they overlap from here on. So that's your domain. Because if you put, say, -1 in here, -1 works for this one, but -1 will not work for this one. Okay? So you use the one that essentially is the most restrictive. That determines your domain. So then the domain would be x is greater than or equal to -1/2. Technically, right, XER. But if you did it in interval notation, you would say -1/2 to infinity includes it, and you can't get to infinity. Okay? Try to contain your enthusiasm. All right. We're done. I'm not going to give you any questions. I'll probably put it. Oh, the range. Okay, what's the range? I don't even know what it is. I'd have to actually sketch this graph. Okay, so put in -1/2. What are we going to get? What's -1/2? X is. Well, this is not going to be fun, people. -1/2 plus 2. Oh, it's going to give me 0 on this one. 2 times a half plus 1. That's going to give me 0. Yep, that goes to 0. What's -1/2 plus 2? That's 3/2. Square root of 3/2. That's your smallest x value. You're taking away more. It's going to open. I think it's √3/2. I'm going to check that, though. Is that what square root of 3/2 is? Is that what square? Okay. Okay. All right, hang on.